Ladies and gentlemen, good morning and welcome to Physical Sciences Grade 12 Trial Examination Memo Discussion. I am Mr. Nambane and I will be just assisting with the coordination of this session as well as ensuring that we have a live broadcast in our YouTube channel as well as the recording thereof. Ladies and gentlemen, with that being said, I don't want to delay any further. I have Mr. Ntsiye, and that Ntsiye is now the subject advisor for physical sciences in the TMED district. He will be the one conducting this session. I hope we have our papers ready as well as the memorandum. Feel free to ask questions, but we'll only take questions immediately after a question or the whole question has been completed by the presenter, such that we can have now a flow of the meeting itself. And the other thing is, if you feel that there is something that you want to say, kindly raise your hand, obviously. And now the other thing will be keeping your mic closed at all times, such that we do not have now sound interference. Ladies and gentlemen, from me to you, thank you very much. And Datenzie, the platform is yours.
Good morning, colleagues. Good morning, Dr. Nambane. Thanks for this opportunity and the organization. May I also take this opportunity to welcome Menel. I see she's in the meeting, and Dr. also he is in the meeting. Colleagues, without much to do, I'm going to do this discussion with the help of Mr. Nambane, like he has indicated. So based on what we have received, for the multiple choice questions, we didn't receive anything. Maybe that was needing a clarity or whatever. So we are going to accept the answers in the multiple choice as they are, unless if maybe there is something that maybe you colleagues can say maybe we didn't, or maybe it is not clear. But for now, we are going to accept all the answers as they are for question number 1. And then the other thing, colleagues, in case maybe there is anything that you want to raise, please also feel free to consult with your subject advisors in your groups. Then they will forward the messages to us and then we'll address them. And then if that be the case, Mr. Nambane, let's go to question number 2, which is based on Newton's laws. And then in question number 2, if colleagues, they do have the papers, the question reads as a block of mass M1 of 8 kilograms is connected by a light inextensible string which runs over a light frictionless pulley to block M2 of mass 8. So the masses are the same. Block M is moving up the incline as shown in the diagram below, and the coefficient of kinetic friction between the block 1 and the incline, it is 0.2. And then the first question, after the drawing, it is state Newton's second law of motion in weights. Now, for these colleagues and all the other definitions, unless otherwise stated, we are going to look at the underlying weights. If any of the underlying key weight or a frame in the correct context are omitted, 1 mark is deducted per weight or per phrase. Network or resultant force should at least be mentioned once in the statement. So the expected answer, it is going to be like when a net force or a net resultant or net force only acts on an object, the object will accelerate in the direction of the net force at an acceleration that is directly proportional to the net force or the resultant force and inversely proportional to the mass of the object. Now, that will be 2 marks. So if everything it is correct the way it is not part marking like it is indicated there, but it should be looking at what is it that the learners have indicated. So we are not doing part marking. And then the other thing about this definition is we got to look if a learner maybe start with force from the equation F it is equal to MA. Force is directly proportional to the mass and directly proportional to the acceleration. That learner will get only 1 mark. That is indicating that the force is directly proportional to the net force, which is that first part there. So that learner will only get 1 mark for that. If he's just making a definition out of the one given as a formula, so that learner will only get 1 mark there. I hope it is clear. Then we go to question 2.2. Draw a labeled free body diagram showing all the forces acting on block M1. Now for that M block 1, it is the one that is on the incline. So it is for 4 marks. Now the indication that we are used to, it is that if it is 4 marks, then it is going to be equal to 4 forces. But that is a very dangerous statement maybe to can do to the learners, because sometimes the examiner might also look at other things like the size of the arrows and something like that. So to say if it is 4, then it is equal to 4, it is not really true. But in this case, then it is applicable. So the 4 forces that are acting on that M1, it is going to be equal to the tension for 1 mark, then normal for 1 mark. We are having frictional force for 1 mark, and then the weight for 1 mark. And then if maybe the learner has decided to use the components of the weight. Now for both the components of the weight in the correct directions, they are going to be equal to 1 mark. So the normal will remain normal, the tension will remain tension, and then the frictional force will remain the frictional force. Now we go to the components of the weight. One, it is going to be parallel to the surface, which is going to be FG or W parallel. And then it must be coupled with the one which is W perpendicular, and we can see that W perpendicular and they must be in the same line. And then that one must just be parallel to the parallel one, must be parallel to the surface. So for both of them, it is going to be equal to 1 mark, and then all the forces with the arrows, they will be equal to 1 mark. Now, if we look at the memo, there are acceptable labels that we are going to apply for this memo. For instance, for the tension, we are also going to accept F and then a subscript T, capital letter T, or force on the rope, or we are going to accept for weight, it is going to be FG or the weight as it is. I'm not going to read the Africans. And then we are also going to look at the normal as Fn or the normal force. For friction, it is going to be F small letter f only, or friction and then frictional force, or the learner can write it in full as kinetic frictional force. Now at this point, colleagues, we are not going to accept things like F fric, where the learner are just putting for friction that it is going to be a fric as an abbreviation. It is not an acceptable abbreviation that we use, because here we are not marking abbreviations, we are marking only the acceptable labels. So 1 mark, it is for the correct direction of the force, the label, and it must have an arrow. If a learner didn't indicate any arrows on that, but has labels, then that would mean that learner, we are going to look at it and say he has all the labels correct, the directions are correct. The only snag that the learner is not doing, it is to put in the arrows. Now we are going to penalize once because it is a repeated mistake. So we are going to subtract 1 mark for that if the arrows are not indicated in all the forces. I hope it is clear. And then the other thing that we are going to do is if a learner is putting an additional force, so we are going to subtract 1 mark also. So by additional force, we mean here we are looking at a total of 4. So if maybe, or if he's giving the component, we are looking at 5. So if a learner, maybe here where we're expecting 4, he's saving a weight, then he's putting another maybe force there. That is going to be an additional force, making it 5. Then we are going to penalize that learner for that, for putting the external force, in fact, the extra force on that one. So the total for that, then it is going to be whatever that learner will be getting. But for this, if it is correct, then it is going to be 4 marks for that question there. Now let's go to question 2.3. Now for 2.3, it says there, consider the forces acting on each of the block separately. And then here we tried to make it easier for the learners because we are looking at this memo also, or the question paper, as a way of also going to teach for towards the end of the year that if we're having 2 blocks, then they must look at them separately. It is not always going to be that they will be given a thing like a statement saying that each block's treated separately. So it is not. But in this case, it was said there, and then they have to calculate the magnitude of the acceleration of the system. So in this case, we're trying to say we are not going to accept the systematic approach. Hence, we put that statement there that at least for each one, the learners, we are just trying to indicate to the learners the approach on how to do this particular question. Now, for this one, the acceleration then is applicable for Newton's second law. Now, we are going to look at this way, that we are going to separate the two. We are going to have for M2 and we are going to have for M1. Now, we are saying we take the direction for the motion as positive. So for both blocks, whatever it is going to happen, we are going to take the direction of motion as a positive. Now, for the first one mark, it is going to be for any of the formulas of Newton's second law, F net equal to ma, or the extension thereof for each block. It is going to be 1 mark. So learners need not necessarily start with F equal to ma, may start with already putting the forces that are acting there, and then it's still gonna get 1 mark. So it is going to be 1 mark for that formula. Now for M2, the forces that are acting on M2, it is the tension and the weight. Now for the substitution there, we don't know the tension, but for the whole of that substitution, it is going to be 1 mark. And then the other mark, it is substituting the 8 multiplied by the acceleration. Now, it is for any of the two because the masses are equal, then it can be for any of the 2 blocks that are going there. So it is going to be 1 mark there. And then the other mark, we are going to now go to M1. Now for M1, we are looking at the forces that are acting in the motion, in the direction of the motion. So in this case, if maybe the components are helping your learners, then let them do that when they do the calculation. So it is going to be the tension. It is going to be equal into a frictional force and then the parallel weight, parallel component of the weight. So all those are the ones that are acting in there. So for that one, it is going to be equal into the T minus the weight and the friction because they are moving in the opposite direction. So that component of the weight, we are going to get 1 mark together with the tension. So that 1 mark, it is for the tension and the component of the weight. And then the other mark, it is for calculating the friction. Remember, they were given only the kinetic friction, the coefficient of the kinetic friction. So the normal, it is not given. So the normal in that case, it is equal into the mass multiplied by gravity and then the cos of 30 because it is equal into that other part of the weight, the component of the weight. So it is going to be another 1 mark. And then from there, we don't mark the mathematics. There's no mark on the mathematics. And the last mark, it is on the acceleration, which is equal into 1.6 meters per second. So as it is there, the question was to calculate the magnitude. So in this case, there is no need for the direction. So that is option number 1. Now we can go to option number 2. If we look at option number 2, it is the same as option number 1. The only thing that we have done, it was to say we change the direction. So we are taking the direction of the motion as a negative. So it is just a change in the sign from the opposite, the option number 1. So it is the same marking criteria, 1 mark for the formula, 1 mark for substituting the weight and the tension that they are in opposite directions, and also here your weight, component of the weight, your frictional force and the tension that are in opposite direction. But the weight, the component of the weight and the frictional force are in the same direction. So it is the same. And then we follow the same procedure like we have marked the previous one there. So option number 1 and option number 2, they are the same. It is just that we change the direction in trying to help whatever way the learners are this question number 2.4. Question 2.4 says that according to Newton's third law, which force is a reaction to the weight of the block M2? So your M2 it is the weight. So for that one, we are saying it is going to be the force that block or M2 it is exerting on the earth for 2 marks. So the forces that the block M2 exerts on the earth, it is going to be the third law or the reaction to the weight of that particular block there for 2 marks. And then question 2.5, while the blocks are moving, the string breaks. What is the direction of the acceleration of block M1 immediately after the string breaks? Write down only up or down the incline. But now in this memo, we'll see that because the incline it is there, then we put it in there in brackets. So now the tension it is not there. Now we know from Newton's second law, then it is going to accelerate in the direction of the net force. So your net force is only that is going to be your frictional force and the component of the weight. So this block it is going to go down for 1 mark, and then the total for that question it is equal to 15 marks. Let's move on to question number 3. Question number 3, it is based on vertical projectile motion. And for that one, we are having the question reading as a crane is lifting a brake on a wooden pallet at a constant velocity. When the pallet reaches a height of 17.2 meters above the ground, one of the bricks falls from the pallet, and then ignore the effect of friction. Now, the position versus time graph shows the motion of the brick from the moment it falls from the pallet until it strikes the ground. So we are given that picture for the crane, and then we are given the drawing of the graph. Now, based on that, the first question is explain what is meant by the term free fall. Now, the expected question was to say free fall is a motion of an object under the influence of gravitational force only. Now, in this case, the context it is motion because it's a fall. So we have to distinguish between the project as an object, and also we have to look at the motion. So in this case, the emphasis it is on the motion. So of an object under the influence of gravitational force only. Now remember, the marking it is to say if any of the key weights are omitted, then we have to deduct 1 mark. So in this case, object can be put in bracket because we are looking at the motion there. So it is the motion under the influence of gravitational force only. So if any of those key weights are missing, then we are going to deduct 1 mark. But the weight motion cannot be left out, because if we left it out, then we are changing the context. So the motion, it is a key weight there that must be there in that definition to distinguish it from being a projectile, because when you say that's an object under the influence of gravitational force, is changing the context of motion to an object. So in that case, please be careful when you address that one there. And then 3.2, write down the time taken by the brick to reach the maximum height after falling off the pallet. Now, based on the graph, we know that at the maximum height, it is when it is reaching that 19.6. That is the maximum height that has been reached by this. So from the position time graph, then the learners were expected to can read that then that 0.7, it is the time that is corresponding to that maximum height. So for 1 mark, then they will have to say it is 0.7 seconds. That is the time that it is reaching to reach the maximum height. So it is 1 mark for that one then. And then 3.3, calculate the velocity of the brick just before it falls off the pallet. Now, in this case, we put in some few options to can look at this one. Now, basically we are saying, as this crane it is moving up, because of the inertia, that brick will still continue to move with that particular velocity. So that is the velocity that it is being asked here. So for option number 1, what is it that we know? We know that at the maximum height, we are having the velocity equaling to 0. So that's why we opted for that velocity, V final equaling to V initial plus G delta T for 1 mark. And then the substitution, it is for the whole of that substitution. Even though it is not underlined there, it is for the whole substitution there. So that means we are saying it is going to be 0 for the final, and then V initial is what we want. And then G, it is going to be negative 9.8 if we are taking positive S upward. So G is going down, it is going to be negative 9.8, and then we multiply by 0.7. So for 1 mark for all of that substitution, and then the answer being equaling to 6.86 meters per second. Option number 2, it is the same as option number 1. The only thing it is that we are looking at downward as being positive. It is the same formula. V final, it is equaling to 0. V initial is what we want. Now G, because it is going down, it is going to be equaling to positive. And then from there, then it is going to be 9.8 multiplied by the time that it takes to reach that maximum height, which is 0.7, and then we end up with a negative value. But remember, this object initially it was going up, so we have to interpret that it is going to go up, and then it is equaling to a positive 6.86 meters per second, because the question says calculate the velocity of the break. So in this case, we look only at the magnitude. We didn't include the direction because it is just before it falls. So basically before it falls, it was going up. So that's why we ignored that particular part there. But in an examination or wherever, colleagues, let's emphasize that fact that for vectors, let's try to put in the direction, because we don't know what the examiner will want in this particular question here. Right, now option number 2, it is to say now here we have this, and then there is a change in position of this particular object just before. So we know that we need this velocity before it can reach that maximum height. So it was already at 17.2, and then it is going to 19.6. So that change in this position there on displacement, it is equaling to 2.4. So we can look at that. So it is going to go for that formula that delta y equaling to V initial delta t plus half G delta t squared. So for up being positive, then the displacement as it is moving up, it is final minus initial. Hence it is positive there because it's still going up. So it is going to be positive 2.4 and then equaling to V initial. Now that V initial there, colleagues, can you see there is at that point there is a delta t missing there. So let's put that 0.7 at that particular point there, because we know that it is 0.7, and then the whole of that substitution, it is the one that it is having that mark. So it is going to be 2.4 and then V initial multiplied by 0.7 because of the formula, and then minus 9.8 and then 0.7 squared. And then that if you calculate, then you go to the same answer of 6.86 meters per second. The same will go for option number 4, which is the same as option number 3. The only difference it is down, it is taken as positive. And then the displacement now, it is going to be negative because the object is still going up, but we are taking downward as positive. So up here, it is going to be negative. So, and then there will be that 0.7 and then 0.7 squared multiplied by 9.8. And then also here, they need to look also at rectifying that velocity there, being equaling to negative 6.86, interpreted to a positive one because it is going up there. Now, option number 5. With option number 5, we have V final, we are having the change in displacement. So that leaves us with that other option of saying V final squared will be equal to V squared initial plus 2G delta Y. So it is applicable because we are having change in displacement. We know that V squared final, it is equal to 0. So 1 mark for the formula, and then 0 squared will be equal to 0, and then v squared initial remains, and then upward it is positive, so your g it is negative, and then we multiply by that change in displacement for going up, which is going to be 2.4, and then the initial velocity then will be equal to 6.86 meters per second. So it is going to be 3 marks, 1 mark for the formula, 1 mark for the whole of that substitution, and then the final answer. And then option number 6, it is the same as option number 5. The only difference it is just changed there on option number 6. That upward there should be negative because we see here it is changing, or downward as positive. Either way we can change it. So let's be consistent with what we are doing. So here it should be downward as positive. So it is going to be delta v final squared will be equal to 0. And then v squared, it is equaling v squared initial squared, and then plus your g now, it is going downward as positive, and then it is going to be positive, and then the change in displacement, it is going to be negative. So we are going to change that upward in option number 6 to downward as positive. Please just do that in your memos, colleagues. And then the initial velocity, we are taking the square root. Now the square root can either be positive or negative, but in this case we are going to take the one which is going to be negative, so that at least we know that that change in displacement, it was going up, it is negative, and then this the object, it is going to go upward. So the final answer, it is going to be v initial equaling to 6.8 meters per second. And then that is how we are going to look at that one. Option number 7. Option number 7 is the same. We are having change in displacement. We are having v final. We want v initial, and then the time is given. So for option number 7, we can still use that delta y equaling to v initial plus v final all over 2, and then delta t for 1 mark. And then for upward as positive, we are having 2.4 equaling to v initial plus 0 all over 2 multiplied by 0.7, and then the final answer, it is going to be 6.668 meters per second. And then cancel that downward or up there. Just cancel it out because we don't need that to be consistent with all the other options. And then also here, like in option number 6, cancel that upward to downward as positive. And then the delta, the displacement becomes negative 2.4, and then v initial plus 0 all over 2, and then 0.7. It is for the whole of that substitution, and then we take the square root of we take that v initial as negative, and then we change it because upward it is positive. Then we are saying it is going to be 8.6 meters per second, and then we cancel that downwards there. So we mark the same as in option number 7. And then option number 9. Option number 9, we are moving a bit away from looking at it as a vertical projectile. We are now bringing in the issue of energy in both option 9 and option number 10, because of the effect that we have to ignore the effect of friction. So that means there are no external forces acting on this. So this system comes isolated, hence we opted for mechanical energy there. So if a learner uses this option, it is still going to be the same, that the mechanical energy initial will be equal to mechanical energy final. 1 mark for that, either that formula or the extension thereof. So mg h plus half mv squared initial will be equal to mgh plus half mv squared final. Now the next object, it is the same object that we are dealing with. So the mass of that object can cancel out in both sides. So hence, if you are looking at that part there, it is not having m's because the m's did cancel out because can be taken out as a common factor. And then the other mark is on the substitution. So we are substituting g S equaling to 9.8, and then also we are looking at 2.4. Now that 2.4, it is the height already. So we are looking at that change in position there as the initial. And then please note that we are saying the kinetic energy there, it is equal to 0. Now, we are looking at this starting from the top going down. So it is important that you look at that. And then finally, it means this object is going to go to the very same position where it was at 7.2 with the same speed, but in an opposite direction. That is the only thing that it is happening. And then when reaching that point, we take that point as a reference. Now that height, it is equal to 0, but the velocity in which it is going to reach that particular height, then we can, that particular height where it is 0, then we can calculate it, and then it is going to be equal to 6,86. So basically for that option number 9, we are starting from the top and then we are going down, and it is going to be marked the same as the previous ones. 1 mark for the formula, 1 mark for the whole of that substitution, and then 1 mark for the final answer. Right, now let's check option number 10. Now with option number 10, we are looking at work energy theorem. Now, based on the definition, explain what is meant by the term free fall. We said the only force acting on this, it is gravitational. So basically the force that is acting here, it is only one, this gravitational force. So that gravity, it is the one that it is doing work on this particular object. And then we are saying that W net will be equal to change in kinetic energy. So it is going to be the masses. Here in the second formula, the masses are the same. Hence, in the second step, there we'll see that the masses have cancelled out. Now, when we substituted the G, which is 9,8, the change in displacement, and then the change in displacement, we are moving from top to bottom. So G, your force G, it is going down, the displacement, it is going down. So your cosine is cosine of 0, hence there it is equal to 1. We didn't show that cosine of 0 there. And then equaling to half V squared is what we want. And then initially this object at the top there at 9.6, it was equaling to 0. And then 1 mark for the whole of that substitution, and then getting the final answer of 8,86 meters per second, 1 mark. So the total for that question, it is 3. And then let's move on to question 3.5. 3.4, not 3.5, sorry. 3.4, it says they calculate the distance covered by the brick during the last second of its free fall. Now, we are looking at this whole object, but we are interested in only the last second. So based on the graph, it means it took about 2.7 meters to seconds to reach the ground. So 1 second before that, that means it is going to be at approximately 1.7. So that is basically what we are looking at. So what is it that we are looking for? Now we are saying for this one, positive marking from 3.3. Remember in 3.3, they were calculating the velocity. So we are going to look also at whatever value that learner got in 3.3, but substitute it correctly in this question 3.4. Now we are marking it as a correct value, and then that learner deserves to get the full marks, even though there was a mistake in the calculation in 3.3. That is basically what positive marking it is saying to us here. Now, the other thing that we need to check with 3.4, for all the options, there is no mark on the formula. So it is only the substitutions and also maybe doing some other calculations there. Now let's look at what is it that we are having here. Remember, in this case, you want the distance. Now, we are looking at the whole motion. Now, if we look at the whole motion, we know that at that point where we are having the velocity at 1.7, we don't know that velocity. But the initial velocity, we have calculated it in 3.3. So we are going to say we are using that formula, but there is no mark on that formula of V final equal to V initial plus G delta T. So 1 mark, it is for the whole of that substitution, the whole of it, that the learner is taking V initial as 6,86 as calculated in 3.3, plus G, it is going down because we set upward as positive, and then the time it took to reach there at 1.7, which is 1 second before it reaches the ground, because it's taking 2,7, so it is going to be 1.7. So that 1 second, it is going to be 2,7 minus 1, which gives us that 1.7. So 1 mark for the whole of that. And then the velocity at that point, when it is at 1.7, then that velocity, it is actually equaling to 9,8 meters per second. But because it's going down, then hence it is negative there. And then what is happening here? Now we are having a mark for the formula only that is leading to the answer. That is where the formula mark, it is going to get a mark. And then 1 mark for that formula there, that now we want the displacement, which is equaling to delta y equaling to v initial delta t plus half gt squared. 1 mark for that formula. Now substituting into that first part, v initial delta t, it is the one that is calculated, and then plus half, and then the 9.8 that it is there, it is for g, and then the 1, it is the time that it is going to take for it to move from that point when it was at 1.7 until it reached the ground. So it is equaling to 1 second, and then it is going to be squared, and then the distance, we know the displacement, it is 14,7 meters. But now, because we want the distance, now that distance then it is going to be equaling to positive 14.7 meters. So 1 mark for that. So the total for the question, it is actually 5 marks. So the first mark, it is on the substitution on the first side, 1 mark for the formula, 2 marks on the substitutions on the formula leading to the answer, and then the final answer here. So for substitutions, we are having 3 marks on the substitution, 1 mark for the formula, and 1 mark for the final answer. And then the other option, it is just taking, which is option number 2, it is taking that part that we have just done to go to the negative side, where we are saying now downward as being positive. It is the opposite of that, but it marks the same. And then option number 3, we are having quite a number for option number 3. And then where do we start? We start first in all the options. If we are looking at that, where we are going to carry over, we are looking at that velocity, where we are that velocity at 1.7. So it is the one that we are going to make use of. So we are having quite a number of options that we can look at. Now we know if we look at that v final equaling to v initial plus g delta t, that we want to calculate that velocity. So 1 mark, it is going to be the same as in that previous one, where we are having v initial coming from 3.3 plus minus negative 9.8 multiplied by 1.7. And then we get that one there, which is 9,8. And then now we can look at velocity that it is going to be having when it strikes the ground. So if we look at that, we are still looking at whatever we are having here. I'll talk to this. And then let's look at this other part, or maybe should we go this way? That now, if we look at that, we want to go and look at the other formulas. Hence, we calculate also the final velocity with which it is going to strike the ground, because we want to put some other options there. So we have to look at what is it that this learner is trying to do. So we can look at that one also for the whole motion. V final, we don't know at which it is going to strike the ground. So we know the initial velocity as equaling to 6,86 plus g, it is equaling to negative 9.8. And then the total time, that means it is for the whole motion, which is that 2.7. And then we'll be getting the velocity with which it is going to strike the ground. So that is another option that these learners can look at. Or what is it that they can be looking? The learner can start also by looking at starting from the maximum and calculate also the velocity. Where he will be having only at the ground where it is going to be. So when he's starting at 0 position, already has traveled 0,7. So his starting time, then it is going to be at 0,7, and then he's going to end up at 2.7. So the difference in time is going to be only 2 seconds there. So that learner can still start there and then calculate the velocity that it is going to strike the ground with. So hence here we see there it is going to be v final equals to v initial plus g delta t. So initially it is at the maximum, it is equal to 0 plus 9,8 multiplied by 2. So the final velocity is going to be 1,96 meters per second. Or as another option, if you look at that other option, you'll realize that we start from the same premise, but we are not at all going to cancel whatever we are doing. So the learner can still say, now let's check. We are starting where we are having the point at the point of launch. Now at the point of launch, what does it mean? At the point of launch, it means the velocity, the initial velocity, it is going to be equaling to 8,6. But that 8,6, it is going to be negative. And then plus 9,8. And now at the point of launch, now it is going to be 0,7 plus another 0,7 going to the point, which is going to be 1.4. So he subtracted that 1.4 from 2.7, and then the time it is going to be equal into 1,3. And then you can calculate that velocity there, which is equal into the final velocity, which is going to be equal into 19,6 meters. Or the other part, it is just to look at the last second. Now, at the last second, what does it tell you? It tells you at the last second, the initial velocity, it is going to be the one that was calculated earlier, which was 9,8, but it is now going down. And then g, it is equal into 9,8 and then 1 second. That is going to be only the distance, the velocity after 1 second, and then it is going to be equal into 19,6 meters. Now, let's go to the options because we know where we want. So all the arrows that are indicating the different options that we have, looking at what the learner it was trying to do. So the first option there, remember we are calculating the distance. We are now having V final, we are now having V initial. Okay, and then we can calculate the displacement. That is option number 3. Now the final velocity is when it is reaching the ground. So when reaching the ground, it reaches the ground with 19.6 and it was going down, then hence it is negative 19.6 squared. And then the initial velocity, it is going to be equaling to 9,8 squared as calculated. And then plus 2 into negative 9.8 delta y. And then the delta y, it is equal to 14.4. But it is going down. Now we want that distance only as a scalar quantity. Then we have to go for positive 14.7 meters. Option number 4, it is the same as option number 3. The only difference, it is that one upward was positive. This one downward, it is positive. So where are the changes? Your initial velocity and your final velocities, their signs and the g are now positive, all of them, because they are going down. And then the distance still it is equal to 14.7 meters. Option number 5. We want delta y, we are having v initial, we are having v final, and then we are having delta t. Now, where are we? We are looking at the initial velocity only at the last minute or last second, and then the final velocity when it is reaching that. So at that final, at 1 minute, the initial velocity was 9,8, and then the final was 19.6. So both of them were going down because positive, it was going for up. So divided by 2, and then the final answer, delta y equal to minus 14.7, and then the distance it is equal to 14.7 meters. Option number 6 is the same as option number 5. The only difference is that downward now it is taken as positive. So the total for that question, it is equal to 5 marks. Now the last question for that, question number 3, draw the acceleration versus time graph for the motion of the brick from the motion it falls from the wooden pallet until it reaches the ground for 2 marks. Now if you look at that one, then the graph, it is just going to give you either your delta G as positive, which is 9.8, and then all your delta G as a negative 9.8. So it is either parallel to the x-axis, positive 9.8, or negative 9.8 parallel to the time axis. 2 marks for that graph, and then the total for that question being equaling to 2 marks. And the whole of that question, it is equaling to 13 marks.
Thank you very much.
Question number 4.
Thank you very
Okay,
much, Nambane.
Nambane.
Just want to check with the colleagues. Colleagues, any questions on question 2 and 3? Says that now we know that Ntatentsiye can go into question 5 if we do not have any questions on question 2 and 3, because I'm afraid that now questions will be piling up on Ntatentsiye, and now it will take
Okay,
us
no,
back.
you are welcome.
Yes.
I see there is a hand.
There is a hand from Reno Pinar.
Hello, sir. How are you?
We are good, sir. How are you?
Good, thank you. In the options for 3.4, I've seen that the only options that are given are the calculation of the velocity, the starting velocity of the last second, where a learner could have calculated the position of the starting position of the last second and subtracted. So they calculate a displacement from the beginning to the start of the last second, and then they subtract that displacement from the total displacement, which will give you the same answer.
Yeah, no, thank you very much for that contribution. Yes, the learners can still do that particular part and subtract the distances. Mr. Rio, can we ask you just scribble us that and then WhatsApp it in the group, and then we'll look at the mark allocation for that one, so that at least you are uniform with everything.
All right, I will do it so.
Thank you.
Thank you very much, colleagues.
Any other questions, colleagues?
Okay, thank you, Ntatentsiye. Thank you, Ntatentsiye. On the chat, we also don't have anything. I'm also checking on our YouTube. The colleagues that are watching.
Mudukanele.
There is Mutukanele. Thank you. You can.
Mr. Mudukanele. Is that an old hand?
Hello, am I audible now?
Yes, you
Yes,
are.
you are.
Okay, no, thank you very much. This is Twinty Tekiso speaking. And Tatensia, we apologize. We might have missed the last part on question number 2, which asks for the snapping of the tension. Where will an object go? And then it was saying down. Is it not gonna go up? Because I think from that moment, 2.5 years, from that moment when it snaps, it is going to start to accelerate, and then it will stop. It will go up first, similar to what the brick has done. Just kindly check that one, please.
Okay, Mr. Tekiso, thank you for the question. Yeah, it will be there, but remember, we still have to look also at not only the observation, but look at what is happening. Hence, the question initially started with Newton's second law. So we have to try and address it with a law that even though it is going to be that, if it is snaps, now the only forces that are acting there, it is going to be your weight, hence it is going to go in that particular direction there. I agree with you. Initially, just for a little moment, it is going to go up, but we are looking at a bigger one. It should go down. It should accelerate in the direction of the force. Mr. Strillman, if Ntate Tekiso is okay. Mr. Strillman. Mr. Tekiso again, Strillman.
No, I'm okay in that. It's just that
Thank you.
adjusting.
All right.
Thank you.
Okay. There is a hand. I can't see you.
It's
Is it Stirman or who has raised?
it's Mr. Man. While we wait for Mr. Man Tatensie, we have a question from YouTube, from Rene Duplessis. The question is at 3.5. Is it 2 or 0?
Yes, sir.
Because some learners omitted the 9.8 value. Is it 2
The
or
question
0?
it says,
Because
yeah.
now some learners drew the correct line, but now they just don't have the 9.8 value.
We have to stick to 2 or 0, Baba. The value it should be there.
Thank you very much, Ntatensie.
Thank you. Can we lower the hands if maybe there are no other questions?
Sorry, Ntatensie, I'm sorry, I was not aware my mic was still muted. I
Okay.
wanted to just ask there on 2.5 also, that word which was included in the question, immediately. Could it not maybe mislead for other learners that immediately when the string breaks, immediately?
Can I look at it the whole, Mr. Man? This object, it was moving at a constant velocity, isn't it? Colleagues? Yes. Now, what does it mean when it is moving at constant velocity? That means all the forces are balanced. Now, which forces are the ones going down and the ones going up are the ones that are balanced. Now you remove the one that makes it to be balanced. What else are you left with? It is going to be the only forces that are pulling down, isn't it?
Yes.
And then based on that, if we apply Newton's second law, what does it say?
It says go down. That I don't disagree with that. I'm just saying maybe with the rephrasing of the question itself, could it not be possible that it could mislead?
Yes, it might, but remember, colleagues, we are using this exercise. Not only for looking at the marks, we are also looking at it, teaching our learners some other things in physics. So that 1 mark, colleagues, can we accept it as it is? That should go down, and then we support, because if the question was the same and then say explain, then if we are to explain, we have to go for physics principles that are going to be applicable, isn't it, colleagues? So let's try to help our learners in preparing them for the final. 1 mark, I understand, it might not look very important, but what is there to us or whoever said this paper was looking at explanation as part of this, although it didn't ask it for the explanation. But when we do physics, let's try to come up with principles and laws that are going to guide us for that. I agree with you that for a very short period of time, then it is going to go up because of the inertia. But in this case, really, let's try our best, colleagues, to help the learners also. Any other hand or lowered? Any other questions, colleagues? So can we stick to that downward for now, colleagues? They will get some bonus marks also. Taitsani, I see your hand, it is raised. Lowered.
Yeah. Good day, Nadensia.
Yes, sir.
Yeah, I'm worried about when you say 2 marks or 0 for 3.5. Sorry for not mentioning the question. We're looking at 3.5 at the graph where you're saying it is 2 or 0.
Yes. Your point?
If I'm reading the question, it says draw an acceleration versus time graph from the motion of the brick from the moment it falls from the pellet. So now,
Yes.
so now that first from 0 up until 0.7, the brick was moving upwards. And then from 0.7 up until 2.7, it is moving downwards. The values of the direction of the acceleration there will be different. That's something I wanted us to look at. Thank you, Dad.
Okay, no. Thank you, Mr. Taitsani. Colleagues, can we look at this and say, Mr. Taitsani, thank you for the question. Colleagues, let us look at the two. In this case, we are given the displacement time graph, okay? I'm not going to address it using this graph, but because Mr. Tatsani is referring to the velocity, to the speeds and that. Now, if it was velocity time graph, the velocities were changing with time. And then from the definition that it is going to be your acceleration. So hence, in each and every formula that we have been using here, I think the values that we put for G, it was 9.8. And then it was either going upward or it was going downwards. That is the first part. The other thing, on the definition, we are saying this object, the only force that it is acting on it, it is gravitational. And then the gravitational, it is the same as the weight. So the weight, it is associated with mg. So the G, based on Newton's laws, it is F equaling to ma. What is it that it is our acceleration? Our acceleration is straightforward, it is going to be G. So there is no way in which you can have any other value. We can calculate the gradient of that particular graph, it is still going to give you 9.8. So colleagues, please, let us try to do the basics correct. So the acceleration here, it is only one acceleration, which is 9.8. And then we want to see as to whether do the learners understand what is it that it is happening here. You can plot all the values that we have calculated, especially when we are dealing with that question of 3.4. We calculate a number of values. Let your learners plot those values to the corresponding times so that at least they get the velocity time graph, and from the velocity time graph, let them get the gradient and talk to the straight line that they get. What is it that it is on the y-axis? What is it that it is changing? It is their time, and try to go for the normal y equaling to mx plus c. Then you will see that the c, it is going to be the initial velocity, and then the gradient of that particular graph is still going to be your g. So the formula applicable for that velocity time graph, it is the one dealing with v final equaling to v initial plus g delta t. That g delta t there, colleagues, is the same as your mx. So please, let's try to help the learners also and help ourselves also. Thank you. I think that last point that I touched on, I'm going to touch it again when we are dealing with that Doppler question, because it was exactly the same thing that was asked there. Colleagues, are you still there? I'm not trying to be imposing everything, but I'm just looking at what is it that we have at our exposure. Tate Nambane. Mr. Nambane?
I'm still here, Ntatensia. You can continue.
Did you take all the questions, Bob? I think so. So let's go to question number 4. Question number 4, it is based on momentum and impulse. It says there, 4.1, A 400-gram ball is approaching a baseball player horizontally in an westerly direction at a speed of 40 meters per second as indicated in the diagram. The baseball player exerts a force of 400 newtons on the ball in an easterly direction. The ball is in contact with the bat for 0.1 seconds. The picture is given and the compass is given. The first question says, define impulse. Now, for that one, we are going to say impulse, it is actually the product of the resultant force or the net force acting on an object, and then the time the resultant or the net force acts on an object. So for that one, colleagues, it is 2 or a 0, as in the memorandum. So it is just a product of the force acting on an object and the time. So for 2 marks. And then, or we accept that impulse is the change in momentum of the object. So then that it is also going to be 2 or a 0. So any of those definitions there, it is going to be 2 marks. Question 412. Calculate the velocity of the ball immediately after contact with the bat. Now, for that one, option number 1, we are taking east as a positive. Now, the formula for impulse momentum theorem, F net delta T equal into change in momentum. So your F net is given, your time is given, and then change in momentum is equal into mass multiplied by V final minus V initial. So it is going to be 400 multiplied by 0.11 mark for that part. And then the 0.4, which is equal into the mass. So the mass is 400, we have to convert it. So multiplied by V initial, and then minus 0.4, it is still the mass, and then the ball, it is not going east because we are set east be positive, so the ball was going west, hence it is negative there. And then the final velocity calculated there, it is 0.6 meters. And then in this case, colleagues, the direction must be included. So it's a vector quantity. So we are going to give 1 mark for the whole of that, the value and the direction. So the total mark for that question, it is 4. 1 mark for the formula, 2 marks on the substitution, and then final answer with direction. Option number 2, it is the same, but east it is now negative. It's still F net equal into change in momentum. So your force, it is going east, and then east is negative, so minus 400 multiplied by 0.1, and then 0.4 V final minus, and then your west, it is positive. So that value there for 40, it is positive, and then we get with the negative answer that must be interpreted to 60 meters per second, and then it goes east. Option number 3, the learner is given the mass, and then the learner is also given the force. So you can apply Newton's second law. Now, no mark on the formula for Newton's second law. 1 mark for the 400 multiplied by 0.4 to can calculate the acceleration. No mark on the acceleration of 1000. And then from the V final equal into V initial plus A delta T. 1 mark for that formula leading to the answer. Now, east is positive. So initially the ball was going west. So it is negative. And then it is accelerating at that 1000 and then for 0.1. And then the final answer, it is going to be 60 meters per second, and then it goes east. Option number 4, it is the same as option number 3. And then we change only the signs, that the force is now in the negative, and then the acceleration it is going to be negative 1000 meters per second, and then V final equals to V initial plus G delta T. And then in fact, A delta T. And then the east, it is 40. That is the speed at which the ball was moving to. It is going west, so it is going to be positive. And then the west is negative. And then the final answer is negative, and then interpret it to 60 meters per second, and then it is going to go east for 4 marks. And then the next question, we move from impulse, we go to conservation of momentum. It says there, when cars are equipped with flexible bumpers, they will bounce off each other during a low-speed collision, thus causing less damage. In one such accident, car A with mass 1,750 kilograms traveling to the right at 1.5 meters per second collides with car B of mass 1,450 kilograms traveling to the left at 1.1 meters per second. Measurement shows that the speed of car A after collision, it is 0.25 meters per second in its original direction. Ignore the effects of friction during collision. Now the picture is given before and then after, so it's a head-on collision. First question, 421, calculate the velocity of B immediately after collision. Now in this case, ignore the effect of friction. That means we are dealing with an isolated system and then there is a collision. So we are having total momentum before equaling to total momentum after collision. 1 mark for either the way it is written or the one given below where there is an extension of what it is happening there. So initially, we are saying right as positive. It is going to be the car moving at right. It was the one with a mass of 1,750. It was traveling at 1.5 plus 1450 into negative 1.1. So 1 mark for the whole of that substitution. And then after collision, the one of 1,750 continues with its velocity, though it is less of 0.25, and then that one of B is what we want. So the final answer, we got that the velocity of B after collision is equal to 0.41 meters per second, and then to the right. Now in this case, colleagues, be careful that there is a mark on the magnitude and then there is a mark on the direction. So 1 mark for the formula, 2 marks on the substitution, 1 mark for the magnitude and 1 mark for the direction. So the answer is 2 marks there, which are separate. And then the other option, it is option number 2, left as positive. So we mark it the same as option number 1. So the sum of momentum before it is equal to sum of momentum after. So we mark it the same. The only difference with one, it is the directions. They are the same. The final answer, it is negative, and then you need to look at that negative. What does that negative mean? So it is going to be 0.41 meters per second, and then it goes to the right. And then option number 3, colleagues, it's the one that we need to discourage our learners from doing that one, because of one rule that is very dangerous. We are looking at that formula. Change in momentum of car A, it is equaling to the negative of that momentum B. So basically, colleagues, if that learner is not writing that negative, the marking rule, it is saying that learner should get 0. Because there is a rule saying it's a wrong formula, basically. But colleagues, let's avoid this because you are putting us in a very awkward position to put this. So for this memo discussion, if that negative is not there, we are going to continue with the substitution and then we give that learner 4 out of 5. But it shouldn't be like that, colleagues. So please, whoever is using this with the learners, it depends on the mood in which the examiners will be, because they can interpret that as a wrong formula. It is not an incomplete formula. It is wrong. It's a wrong principle. So if the principle is wrong, you cannot come up with a formula from a wrong principle. So, but for this, the purpose of this memo, we are going to deduct 1 mark for that. And then It is on that. And then also please be careful when you go to that other part there about the signs there. So we are going to mark it, 1 mark for the formula, 1 mark for the substitution on the left, and then 1 mark for the substitution on the right. But also on the substitutions, colleagues, let the final be the final. The learners shouldn't swap, because immediately that they swap, then we look at it as an incorrect substitution. So we cannot give marks for that. And also the signs, colleagues, they must be corresponding to the change. So that is the only thing that we can look at that particular point. Okay. Option number 3 and option number 4, they mark the same. So the only difference, it is only the signs that are changing there. So the total for that question, it is equaling to 5 marks. And then question number 4.2.2, when the cars are equipped with flexible bumpers, they bounce off each other during a low-speed collision, thus causing less damages. Explain how flexible bumpers reduce damages during the low-speed collisions. Now, here, colleagues, we are saying, what is the flexible bumper doing? The flexible bumper reduces the net force. But how does it reduces the net force? By increasing the time required to bring about the same change in momentum. Basically, we are using that formula of impulse, that there is an increase in time, then the net force, it is being decreased, but for that to be there, that change of momentum should be constant or should be the same. So that is where the 3 marks it is, and then we are going to mark it the way it is, colleagues. So we are looking at the force, we are looking at the time, and then what is happening to the change in momentum. And please, colleagues, it is the change, not momentum. It is the change in momentum there. So the learner cannot say momentum is the same. It should be the change there. The total for the question, it is 3, and then for the whole question, it is 14 marks.
Thank you very much,
question number 4.
Thank you very much. We have a hand from Me Alta Fori on question 4. Me Alta.
Good morning, Mr. Nsia. I just want to find out from you. The learners say reduce the net force, but they leave out force, the net to the force, but then they use the formula to explain further. Or they say F net in the formula is delta P over delta T. Must I penalize for the net force, or can I allow a mark because he used net force in explanation further? Thank you.
Thank you, Mayor Fori. No, we are going to look at it because basically it is the same as Newton's second law. So the net force must be mentioned at least once, then it is fine with me.
Mr.
Any
Livenia?
other hand I see?
Mr. Livenia?
Hello?
Hello, sir.
Yes, sir, we can hear you.
Am I audible?
Yes, you are. Yeah.
Okay. Tatensia, thank you so much. I'm asking with regards to 4.2.1.
Yes, Baba.
It's actually at the answer. I'm aware that we've got 2 marks for the magnitude and direction as well there. So I'm not quite sure if you've mentioned it, but the direction is independent of the magnitude. Am I right?
You are all right, Ntate Benya, they are independent. We mark them independently. Okay. Yes, sir.
All right. Thank you so much, sir.
Thank you.
Alta, your hand is still up. Is it an old hand? Or just a follow-up? Mefori? I think it's an old hand.
Excuse me, I was listening to something else at the moment. Can you repeat? Sorry, my hand's old hand. Sorry.
Okay.
Oh.
Thank you very much, Me Alta Tatensiye. I don't have anything also on the chat as well as the YouTube, so I believe it's an indication that you can go to question 5, say.
Thank you very much, Ntate and colleagues. Thank you very much for your contributions, and we are welcome any point, any day. Question number 5. Question number 5, it is on work, energy, and power. And then it says there, after an emergency landing at Bloemfontein Airport, a passenger of mass 70 kilograms evacuates the stationary aeroplane using evacuation slide. That makes an angle of 40 with the horizontal. When the passenger reaches a height of 2.8 meters above the ground, the passenger has a speed of 0.5 meters per second. Now, 5.1, define the term non-conservative force. The expected answer, it is a force for which work done in moving the object between 2 points depends on the path taken. But you can see that in moving the object between 2 points, we put it in bracket. That means it can be ignored. So we can accept it as a learner maybe put it, a force for which work done depends on the path taken. And that will be 2 marks, colleagues. So nothing is underlined here. So that means there is no other way. It is either a 2 or a 0. But the other thing, colleagues, in this case, let's put it to our learners. This question is coming each and every time. Because it's a force, the learners tend to think it is a force and not work done. So let's maybe conscientize our learners about that. And then, as we proceed, a constant frictional force acts on the passenger as he moves down the slides. Now, 5.2, draw a labeled free body diagram showing all the forces exerted on the passenger. Now, in this case, it is 3 marks. So we still have the normal. We are still having the friction going up, opposing the motion, and we still have the weight of that particular passenger. Colleagues, we didn't include the other part where we are using the components of the weight, but they are going to be acceptable, like in question number 2. And then for both the components, it is just going to be 1 mark there. So it is going to be the vertical component and the parallel component of the weight, which are going to go there also with their correct directions. Then we are going to accept that drawing there. Okay, and that would be 3 marks. And then 5.3, name a non-conservative force acting on the passenger. The only force which is non-conservative acting on the passenger, then it is equal to, it is actually the frictional force for 1 mark. And then proceeding, the coefficient of kinetic friction of the surface is 0.112. Now, use energy principles. Using energy principles, calculate the velocity of the passenger at the lowest point of the slide for 6 marks. So based on that, we try to draw that slide and then the angle, and then try to look to allocate, maybe to annotate that X. So basically the emphasis on X, what is that value of X? So it is going to be the sine of 40 will be equal to that 28, which is the opposite side, all over X. And then when you calculate X, it is equal to 4.35. So we use that one only to indicate maybe the learners can put that 4.356 already in whatever that they are doing. So hence we have that value there. Now let's go to the questions. So the energies that we apply, it is either we apply work energy principles. So it is going to be work energy formula, 1 mark for option number 1. So work energy theorem. So what is it that it is happening along that Y? it is either going to be your FG parallel. Hence, I said maybe in the first way they were to draw a free body diagram, it didn't include that components, but they can use it. So it is going to be FG parallel plus the weight. Those are the ones that are acting there. Then they're going to be equal to half mv squared minus half mv squared initial there. And then your parallel, it is equal to FG component, and then delta x cosine of theta. That is the work that is being done there. And then we substituted. So the mass, it is 70, G, it is 9.8. The component, it is actually the sine of 40. That is that component. So 1 mark, it is for that component there as it is. And then the displacement, no mark, and then the sign, it is not on that. So the emphasis, it is on that one there. And then plus, now we go to friction. The frictional force, we are given that value of 0.11, which is the coefficient. The normal, it was not calculated. Now they have to go and calculate the normal, which is equal to that component of the FG perpendicular. So that component of perpendicular, the whole of that substitution there, 1 mark. It is unlike this one. So here it is for the whole of that substitution, right? And then I think because that one part, first part, before I move on, it is also underlined. So that means that 1 mark on the 40, sine of 40, it should be for the whole of that substitution. Just the same as in this one here. Because you see it is underlined, the whole of it there. And then the third mark on the substitution, it is on the cosine of 180. So the displacement remains the same. And then on the other side, half 70 v squared final, and the substitution of 0.35, it is for that part there, that change there, 1 mark for that one there. So, and then the final answer of 6.905. So let's repeat. 1 mark it is for any of the formulas. 1 mark it is for the substitution on the left-hand side. That one calculating the work done by the work perpendicular. The other mark, it is work done by friction. So it is only the frictional force, how it is calculated. And then the whole of that part, it is 1 mark. And then the 180 mark, and then the change in momentum. It is, in fact, in the kinetic energy, it is another mark. That value is there, that negative, that it is 1 mark there. And then the final answer. Now, if you go to the next option, option number 2, it is the same as option number 1, but the difference, just go down a bit, Mr. Nambane. So that the two options can be together there. You see, in the first option, we are having 70 sine of 40. In the second option, it is the same. We are having 70 cosine of 50. We only look at that part. That is where they change. We look at the co-function of that. So that is where the difference is. And then you can see the whole of that part, it is underlined. So that mark, like I indicated, it is for the whole, so that at least you are having the same thing here. So with that one, that mark, it is not only on the 70 sine of 40, but it is for the whole because it is everything underlined. So that it should be the same as in this option number 2 there. So please take note, colleagues, there. And then the other mark, it is the same. It is the same here. And then there it is the same. And then that part of the change, it is still the same. So the marking, either option 1 and option number 2, they are the same. And then option number 3. Option number 3, we ask the learners the name of the conservative force that it is acting there, then it is friction. So we can go for work done by non-conservative force. So equaling to change in kinetic plus change in potential. Now your kinetic, your non-conservative force, it is going to be a friction. So what is happening here? It is going to be that substitution mark for the non-conservative. So it is going to be for that frictional force. And then the 180, just like in the previous one. Now here we are having the change in kinetic energy and then the change in the potential. So we are still having 4 marks on the substitution, 1 mark on the formula and the final answer, just like in any other options above. that we are having this. So they mark the same. They are marking the same. So any of the formulas, 1 mark, 4 marks on the substitutions, and 1 mark on the final answer. The total for that question, it is 6 marks. And then the next question, it is now going to 5.5. The angle between the horizontal and the slide is increased. How will the change influence the frictional force acting on the passenger? Now, what is going to happen? We say write only increase, decrease, or stays the same, and then we explain. Colleagues, my plea is first, let's encourage our learners to come up with the explanation before they go to increase, decrease, because this in the previous years, it should have been a negative marking type of a question. So that decrease, or stay the same, it is a conclusion. So let's encourage them to come up here with the reasoning before they go to increase, decrease, or remains the same. So, but in this case, there is no negative marking, still suspended for now, but we don't know until when. So the answer, it is going to decrease. Why it is decreasing is because the normal force decreases for 1 mark. And then why is that the case is because frictional force is directly proportional to the normal. So the learners can put it in weights or can put it as a formula, or maybe take out the mu as a constant and put it as a relationship for 3 marks. So 1 mark for decrease, 1 mark for the normal decreasing, and then it is for the relationship between frictional force and the normal that the 3rd mark is allocated. So the total for the question is 3, and then for the whole of that question, then it is 15 marks. Any other questions? If we do have, let's take them. If we don't, maybe proceed to question number 6. Should we continue, colleagues?
We can go to question 6 in that NTA. I don't have anything on my side as well.
Thank you, Baba. Question number 6, it is on Doppler. And it says a learner investigate the relationship between the ratio of the observed frequency to the source frequency. And then, so it is FL and FS, and the velocity with which the listener moves relative to the stationary source. The experiment is repeated by increasing the magnitude of the constant velocity with which the observer moves relative to the same stationary source. The observed frequency, which is FL, is recorded, and the ratio FL over Fs is calculated for each experiment. The graph below shows the results. Now, we have that graph along the y-axis is Fl over Fs, and then along the x-axis, it is the frequency of the listener. In fact, the velocity of the listener. Now, 6.1, state in ways the phenomenon described above. So the phenomenon, it says the state in weights, not mention the phenomenon, state in weights. Basically, it is just what is this state, the Doppler's effect in weights. That is basically the same question. So we expect it to be, it is the apparent, or maybe that's the change in frequency or pitch of sound detected by the listener, because the sound source and the listener have different velocities relative to the medium of propagation, or an apparent change or observed or detected frequency or pitch or wavelength because of the relative motion between the source and the listener. So in this case, it is part marking. So 2 marks for that one, colleagues. And then use the graph to answer the following questions. 6.2, is the listener moving towards or away from the stationary source? Explain. Now the reason and the answer, it is moving towards. Why is that the case? Is because as we are proceeding, as we are looking at the graph, that value of FL over FS is becoming greater than 1. So initially it was 1, but now as it is now changing the velocities, then it is greater than 1. Or option number 2, the ratio FL over FS is increasing as FL it is increasing. So 2 marks for that one there. 1 mark for the towards and then 1 mark for the reason. And then 6.3, what does the gradient of the graph represent? Then it represents 1 over F, 1 over V. No subscripts on the V, please. 1 over V, which is 1 over the speed of sound, not any other V. 6.4, calculate the speed of sound in air during this experiment. We are having 3 options there. We can use any set of values from the graph. Now, the first option is to say, basically, that first option, it is based on what we have here, a straight line. We are having y equaling to that one, VL over V plus 1. So that is a straight line. If you are looking at that, y equals to mx plus c. Your c it is 1. Your v at that point, they took it at 1.6 when the speed it is 20. So they are looking at that one there. And then they calculated the speed to be equal to 333.33 meters per second. Or we can look at the gradient as it is. So on the gradient, what is it that we are having? The gradient, it is equal to the value, change in value of y over the change in values of x. So they choose 1.6 and 1. So, and then we can see at 1.6, then the speed it is 20, and then at 1 that the speed it is equal to 0. And then they calculated that 1 over v as the gradient that it was asked in that other question, and take the reciprocal. Then your v it is equal to 33.33 meters per second. Then that is going to be. And then the final option, it is using the Doppler as it is. So it is a Doppler equation and then simplify it. So we are having VL over VS equaling to V plus VL because it is moving towards all over V, which is a stationary. So we use that one, and then that value VL over VS, it is 1 over 6 V, we don't know. And then at 20, that is where we are having 1.6. So the V is unknown, and then calculating the V, we end up with 333.33 meters per second. Now, how do we mark? It is 1 mark for any of the starting equation in option number 1 and option number 2. 2 marks on the substitution and the final answer. And then in that option number 2, it is the change in x, 1 mark for the whole of that. And then 1 mark for the whole of that. But for the value of 1.6, that it is common everywhere, then there is a mark. So above the line for this option where they're using the gradient, above the line we're having 2 marks, and then the final answer. So interpreting that the reciprocal, there's no mark there. So it is basically, we are having the marks as they are in that particular option there. So the total for the question, it is equaling to 4. Hope it is fine. And then question number 6.5, an observation of the spectrum of the distant stars shows that it is moving away from the Earth. Explain in terms of the frequencies of the spectral lines. How is it possible to conclude that the star is moving away from the Earth? Now, what we are looking at, that the spectral lines of the star are shifted towards the lower frequency end, because the question was saying talk to the frequency, so they are moving to the lower frequency end, which is the red end of the spectrum, which is 2 marks for that one. Hands are raised. Let's take the hands at the number.
Yes, colleagues. Marisa Smith.
Marisa?
Are you hearing me? Hello?
Yes, we can hear you now. Yes,
Okay.
proceed.
I have two questions. First of all, at 6.2, if the learner's reason was an increase in frequency, can we award a mark?
6.2.
Yes.
Which frequency is referring to?
If they just said the frequency is increasing.
Yeah, but we are having two frequencies here. The one for the listener and the one for the source. So which one is he referring to?
No, they didn't specify, just an increase in frequency.
Yeah, no, let's give one for towards.
Okay. All
Yes.
right. And then going from 6.2 to 6.4, if the learner at 6.2 said away, which is incorrect, and then at 6.4, when they use the formula for Doppler, they use the formula for away instead of towards. So they are using a negative instead of a plus there in the Doppler formula. Do we continue with positive marking, or do we just mark the whole thing as wrong?
Oh, Marisa and the learners. Okay. Mr. Nambane, just maybe at 4.4, just put it that you are going to take positive marking from 2.2, 6.2.
6.2 to 6.4, we can use positive marking.
Yes.
Okay,
Yes,
thank you.
I see Alta. Marisa, just lower your hand in case you do have no more questions.
Alta's on now. That wasn't Marisa,
Yes,
that
Alta.
was Joy. I just also have a question then at 6.2, the same as what Joy had there, but only the learner says the observed frequency increases. Can we award a mark?
Only there?
And then he says the observed frequency increases as a reason.
Yeah, yeah. For that one, I think we can give a mark because it's specific which one it is going to increase. Based on that graph, then it is okay.
And then 6. Thank you. And 6.3, instead of saying 1 over V, the child says the speed of sound in air.
What does it say?
He says the speed of sound in air.
Yeah, but it is the reciprocal of it.
I see it's a reciprocal of.
Yeah, if you say the reciprocal of speed of air, then it is fine.
He said reciprocal. Okay, no, he didn't. Thank you very much.
My pleasure. Mr. Libenya, lower your head, Alta.
Hello?
Yes, sir.
That is I'm not sure. I think it's similar to the question asked by the previous educator. It's 6.3. Let's say for argument's sake, the learner just wrote V there instead of the reciprocal of it. And then moving to 6.4, if you look at the option 2, wherein it says here 1 over V, but the learner who may have written in 6.3 just V and continues with that for option 2 in 6.4 and regards that to be his answer, can we still apply positive marking?
Mr. Nambane, can you show the memo? To 6.4, what do you have written? Is it okay, Mr. Libenya? Or should we also, is the case?
Yeah, like option 2 there, it says 1 over V. But my question is, perhaps if the learner in 6.3 just wrote V instead of the reciprocal, and then here in 6.4 for option 2 continues with the V instead of 1 over V.
Let me quickly go through it again. Can you just give me a minute before the end of this? I'll answer to that one, Mr. Libenya.
Okay.
Yeah.
No, it's fine. All right.
Okay. All right. Okay. I'm afraid we are going to deviate too much from the memo. That's why I'm taking maybe a bit of it. I'll look at it, that's 6.3. Okay. Actually, didn't we say, okay, no, I see. I think, Mr. Nambane, for that one, 6.4, because of that mistake that the learners are using, and in one of these options, especially option number 2, maybe for that option number 2, we can apply it, positive marking also for from 6.3, because they're going to get it wrong. But we are marking the scale in any way.
Noted that I have something from Mr. Mabina through YouTube. He's asking 6.4. Some learners have points in the graph and the values ranges between 320 meters per second to 333 meters per second. Can we please check that?
Yeah, in case there is a range, we are going to accept a range, and hence we said any values in the memo that use any values. So it means if maybe here we make some example, and then if maybe the teachers, when they mark, they see that the substitutions are giving the correct answers, then there will always be a range. And then if it is in the acceptable range, then we'll accept that acceptable range in that.
Thank you very much. I also have one from Makaki Lepele. It is at 6.2. It's actually this option number 2 where it says, now if the learner just says FL over FS increases, do we award a mark? That is now without saying VL increases.
That means at that point, they're making our life very, but how is that increasing? It is increasing because of VL, because that they need to talk to the graph. The graph at the value of Y, it is increasing. What causes it to increase is because there is an increase in the value of X. I think let's give our learners the opportunity to can fully explain, and in future not just accept anything that the learners are doing, because there will be this thing that we know they are going to accept. So let us not accept it. Because there must be an indication why it is increasing that value there. Hence we are putting it, it is greater than 1, or as the VL it is increasing.
Thank you very much, Ndatensiye. That's all I have from the colleagues on YouTube.
There was Mr. Mabiti also.
Yes.
Is that all? I see there's still a hand.
Good morning.
Yes, Ntate.
And good morning to you, Ntate Ntsiye and Ntate Nambane there. Thank you for all the inputs. We are making changes here. But however, I wonder if I would have the power of persuasion. Looking at 6.1, stating with the phenomenon described above, at first glance at this question, my feeling was Doppler effect should be also correct there, because this question, I feel that for most learners, it did not come out as clear as you put it. Can we consider perhaps learners that have specified a Doppler effect as the answer? Thank you.
Thank you, Mr. Mabiti, but let me put it that we are not going to accept that, because basically that question, it is saying to the learners they should be knowing this is Doppler effect because of the way the statement it was put. The statement was explaining exactly what is Doppler. So this, it was to say, just state Doppler's effect in weights. Hence the question, state the phenomenon in weights. So it is the way it is, let us not waive that one. please.
All right, Ntate, thank you.
Okay, Baba. Can you lower your hand? Thank you. Are we okay, colleagues?
Thank you, Ntate.
Can you go to question 7?
I think we can. Okay, this
Ntate
Mr.
Mudukanele.
Mudukanele.
All right. Thank you, Ntate Nambane, Ntate Nsiye. This is question 5.4. Ntate Nsiye, I've had you on the first part, option number 1. You first said the mark, the first mark on the substitution should be the FG, the whole substitution of FG delta X cos theta, plus the second mark you said it should go to the substitution of how friction is being calculated, and then the last mark should go to cos 180. And then where I've corrected it was this underlined, which was not under the delta X, should be on that delta X as well. Meaning the second mark of substitution, you are saying it should look like what we are having on option number 2. I want to hear if that is correct.
It is correct. We mark option number 1 and option number 2 the same, Baba.
Oh, okay. Yeah, that didn't say. I just wanted to check, perhaps, but then of course it will be on your decision. Would it not have been better if this cos 180 mark was coupled with delta X? I don't know. I think it, because on the other side it's just too long, and cos 180 on its own deserving 1 mark, really.
Yes, but you remember at some point I did indicate that for that 1 mark in that other question where you were saying maybe we are too harsh. Here we are trying to be also not to be too harsh on the learners, for them to differentiate between the 0 and the 180. That's why that mark was there. So can we give it to them? It was given to them.
All right, thank you, Tati. Thank you.
Thank you, Baba.
We can go to question 7, Tatenzi.
Okay, Baba. Let's go to question number 7, colleagues. Question number 7, it is on electrostatics, and then it says the 2-point charges A and B carries charges of positive 1,2 nanometers and positive 1,5 nanocoulombs, sorry, not meters, coulombs, respectively placed 5 centimeters apart along a straight line in a vacuum as shown in the diagram. An electron is placed at point X 4 centimeters to the right of point charge A. 711, state Coulomb's law in weights. Now for 7.11 part marking, the electrostatic force exerted by 1 point charge on another point charge is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Now, in this case, colleagues, it is part marking, then it is going to be 2 marks. And then 7.12, calculate the net electrostatic force experienced by the electron. So from here, it is application of Coulomb's law, formula. Now, in this case, you are having 2 charges that are exerting a force in that. So either our learners are going to combine the 2 or they're going to go separate like we have done it here. So if they go combined, colleagues, please look, it is going to be that third part there where we are having F net. So it is going to be F net equaling to FEA plus, or they can still use minus there and then put them negative, maybe the other side. But there must be an indication of the difference between the two if it is combined. But if they approach it this way, like we have done, then it is going to mark the same, like they have put everything in the whole. 1 mark it is on any form of Coulomb's law. Then the second mark, it is on the substitution of that charge of 1.2 multiplied by the charge of an electron. So that whole substitution, and that electron, it is now placed at x, which is going to be 4 multiplied by 10 to the power minus 2. That means dividing by 100, all that squared. 1 mark for that. And then the other mark, it is on the substitution, where you are having that charge of 1,5 multiplied by 10 to the power minus 9, and then the charge, which is now the electron, which is now the distance between the electron and the charge, it is 1 centimeter, so that's squared. So that is going to be your 3 marks. The fourth mark, it is on subtracting. It is on the negative. That mark, it is on the negative. And then the final answer, because if you look at that, it says there, calculate the net electrostatic force. So in this case also, we emphasize the vector, that part, it is a vector, then it is a direction coupled with the final answer. So the total for that, it is going to be 5 marks. I hope that one is clear, no questions about it. And then 7.2, it says there, calculate, in fact, point P is a point in an electric field 0,03 meters from charge sphere A as shown in the diagram below. The electric field experienced at P due to the charge sphere A, it is 4 multiplied by 10 to the power 7 Newton per Coulomb to the right. Now 7.21, calculate the magnitude of the charge on A for 3 marks. Now for that one, we are given the electric field. They want the charge, they have given us the distance. So it is E equal to KQ all over R squared. 1 mark for that formula. 1 mark for the substitution of electric field, and then the K, and then the conversion of that 0. In fact, it is already converted that distance. So 1 mark, it is for the whole of that substitution. And then the charge, it is equal to 4 multiplied by 10 to the power of 6 newtons, so coulombs. So 3 marks for that calculation. And then 7.22 is the charge on sphere A, positive or negative. Now, the electric field, it is given, it goes to the right. So electric field is always moving from positive to the point which is negative. So, so it is going to be A positive for 1 mark. And then 7.3, a point charge X carries an excess of 938 electrons, is now placed at point P. So what happens, they say calculate the magnitude of the electrostatic force experienced by a point charge X. Now, the first thing, it is to calculate, because we are given the number of electrons, so it is to calculate that charge. So the number, it is going to be charge equal to number multiplied by the charge of an electron. So we end up with the charge of 1,5 multiplied by 10 to the power of negative 6 coulombs. So that 1 mark for calculating that charge, it is on the substitution. Now, option number 1, we have calculated, in fact, we are having the electric field that was given. So it is equal to F over Q. So 1 mark for that formula, and then 1 mark, it is for the whole of substituting the electric field and the charge that was calculated there, and then getting the final answer of 6 multiplied by 10 to the power minus 9 coulombs. It is one that we can maybe also look at as an example. And then the other one, it is where we can say the learner can still calculate, is having the electric field, and then he is having the distance. He can calculate that charge, which is there. What we're gonna get, and then from there apply Coulomb's law. So it is going to be that charge that was calculated in that at that particular distance for that in that electric field, which is 4 multiplied by 10 to the power negative 6 coulombs, and then applying Coulomb's law, F equal to KQ1 over K2, K it is equal to that. Now the charge given for A, it was 1.5 as it was calculated at that point there where we are calculating the number of electrons, and then the new charge that has been calculated at that particular distance, and then we calculate that force to be equal to 6 multiplied by 10 to the power minus 9, and then newtons, and then the total it is 4. The total for that question it is equal to 15. Brian Morgan, I see your hand, it is up, sir.
Good day, sir. Thank you very much. Can you please return to question 7.2.1?
721.
Yes.
Yes, sir.
Okay. Mathematically, please just check me. Isn't it 4 times 10 to the power of 12?
12.
Yes.
Can someone quickly check that for us, colleagues? Will do. I don't have a calculator near me, but maybe colleagues can verify that one, and then if that be the case, we'll rectify it, sir.
Thank you.
Okay, Mr. Brian. I see there is another hand. I don't see who has a hand from my side. Oh, Mr. Taitsan, your hand is up.
Good morning once again, sir.
Yes, sir.
I want us to have a look at 7.1.2.
Yes, sir.
If we can accept the following option. If a learner decided to calculate the net electric field at point X, after determining the net electric field at point X, then goes further to use the formula of E is equal to F over Q to calculate the F. And then if we accept it, and then please indicate the mark allocation. Thank you.
Can you also ask you just to send it through to us, and then we'll put it again, sir?
Yes, I've forwarded to Mr. Nambane already.
Okay, no, okay, we'll look at it back. And we'll put it in a group if possible. Yes. Okay, thank you. Any other colleagues? In the absence of any, let's go to question number 8. Question number 8, it is on electric circuits. And it reads as, the diagram below shows a circuit with a battery of EMF 12 volts and internal resistance R. The battery is connected to resistors of 25, 20 and 5 ohms and resistor X of unknown resistance. The ammeters, switch and conducting wires have negligible resistance, while the voltmeter have a very high resistance. So we are given that diagram there. And I think the only thing that I have, colleagues, that I have to ask, it is maybe the diagram as we move from Word to PDF, some of the lines they did move, but it is closed. Everything is closed, even though we have some gaps here and there. Please, let us not make an issue out of it, please. And then 8.1, explain what is meant by EMF of 12 volts. So in this case, we expect it is going to be 12 joules of energy is transferred per coulomb of charge. So that it is going to be 1 mark on the 12 and then per coulomb of charge. For another mark, 2 marks for that. And then when switch S is closed, the reading on the ammeter A2 is 0.2 amperes, and then the reading on voltmeter V2 is 5.5 volts. 8.2, calculate the 821, the reading on ammeter A1. So that ammeter A1, it is actually giving us the total current. So we are having current in the parallel branch, where we are having 25 and 5, it is the same current. So we took that and then it is parallel. Now for option number 1, we are saying that the potential difference in the branch, it is equally in the 20 and the sum, which is the 30, the 25 and the 5, they are equal. And then that current, we can calculate the current, therefore, in that other branch of 20 to be equaling to 0.3 amperes. And then for the total, which is going to be your current in the A1, it is going to be 0.3 plus 0.2 going to 5. So 3 marks. The 3 marks, it is basically on the substitution and the addition and the final answer. And then option number 2, it is the same. V across the 30, which is the 25 and the 5 amperes, it is equal to the current in each, which is the 0.2 in the 25 plus the 0.2 in the 5, because the in series give you a 30. So they give you 6 volts. So that 6 volts, it is for equaling to the 30, the 20, and the parallel, they're equaling. So we are having 6 volts, it is equal to current in the 20 ohm resistor, which is equaling to 6 multiplied by the current divided by, and then the 20. So dividing both sides and then adding the 0.2, we still go to 0.5. Option number 3, it is to say the V across the parallel, it is equaling to 0.2 multiplied by the 30, which is the 25, and the 5 going to 6 volts. Now from there, what is it that is happening? Then the learner can calculate the equivalence resistor of the parallel, and that works to 12 ohms. And then the parallel, it is equaling to that in that part there. And then we can get the total current in that parallel combination to be equaling to 5 amperes. 3 marks for that. Any of the 3 options or any applicable option, then you are welcome to post it and then we look at it. But basically, we can see that it is about the substitutions, no marks on the formulas here. So 3 marks for that. And then 8.22, resistance of resistor X. Now it is positive marking from 8 to 1. So that resistor X, it is equaling, we apply Ohm's law, it is equaling to V2 all over the current that it is going to go there. So V2, it is given as 2.55, and then the current passing through the total current, which is 0.5, and then that gives you 11 ohms. So 1 mark on the formula for Ohm's law, 1 mark for the substitution, and 1 mark for the answer, 3 marks for that one. And then the next question, total resistance of the circuit. So for that total resistance of the circuit, depending on what the learner has done, then can be positive marking from 8.22, getting that resistor of the 11. And some they will start with the parallel, but some will not start with that parallel. If maybe it was calculated like in one of the options above, then just have a look at it, because some of the learners will just take it up there and then put it there. So we can start first by calculating that parallel. And then the parallel is equaling to 12 ohms. And then the external, it is going to be parallel plus series, which is going to be 12 plus 11 goes to 23. So it is going to be either that formula or the one where we are using the product sum, and then the substitution into that getting to 12, and then adding the 12 and 11, and then getting to 23 ohms. So the total for that, it is 3 marks also. Question 8.24. We have to calculate the internal resistance of the battery. Now, in this case, we can apply the EMF. The EMF equaling to EMF equals to I into R external plus R internal. So your EMF, it is equaling to 12, your current it is 0.5, the external is equaling to 23 plus R. Now we can calculate that R to be equaling to only 1 ohm. Or alternatively, what we can calculate, it is to say we calculate the V external. Remember in that we are having V external, though we didn't show it here, but it is the I multiplied by R total, where we are having the total current is 0.5, and then the total resistance, it was equaling to 23. So half of 23, it is 11.5 plus 12, and then goes to 0.5. Now the lost volts, which is 0.5, will be equaling to 0.5, and the total current passing through it is 0.5, and then we end up with 1 ohm as an internal resistance of that battery. And then 8.3, resistor X is replaced by another ammeter. Now, will the reading on the voltmeter V1 increase, decrease, or remains the same? Explain the answer. Now, when you put an ammeter in the statement, they told them that the ammeter have negligible resistance. So basically there is no resistance. So what is going to happen? Then the resistance, it is going to decrease. If we are removing that X there as a resistor, and then becomes a parallel, because of the parallel, then the total resistance decreases, the external resistance, it is going to decrease, and the current is going to increase. So the combination of the two, it is 1 mark. It's not separate. Total resistance decreasing, the current increasing 1 mark, and then the V lost, they are going to increase. And then because the V lost, it is going to increase, therefore the V external, it is going to decrease. Then the reading on the voltmeter, then V1, it is going to decrease for 4 marks. And the total for that whole question, it is equaling to 18 marks. I don't see any hand. I don't know of if there are any on the chat. I don't see anything. Okay, there's a hand from Marissa Smith. Ms. Smith.
Hello, it's Joy again.
Okay, Joy.
Hi, 2 questions. At 8.2.1, if the learner used the ratio between the current in the 2 parallel branches and got to the correct answer of 0.5 amps, can we still award 3 marks?
Yes, ma'am, we can. Using the ratio in the ratio of 3 to 2, then
Yes.
it is fine. Yes.
Okay, right.
Yes.
And then at 8.2.4, can we apply positive marking if they got the answer at 8.2.2 wrong and substituted it into the correct formula at 8.2.4?
The wrong answer for 8.22, for 8.23.
At 8.2.2, they calculated the wrong resistance there, but they substituted into the correct formula at 8.2.4. Can we apply positive marking?
Yes, we can apply positive marking there, ma'am. Yes.
Okay, thank you very much.
You are welcome. Tate Libenya.
That is your hot happen. 8.3. I'm not sure if you've mentioned that, but can we apply negative marking?
Okay, colleagues, Mr. Libya, can we reserve the negative marking for now, because we are still applying it according to the national standards now. We don't know until when. Yeah.
All right. Okay.
Yes,
no, it's fine.
Yeah. Okay, but any other colleagues? All right. In the absence of any, let's go to electrical machines, which is question number 9. Question number 9, it says there, the diagram below is a simplified representation of a generator. The coil rotates clockwise, and then we are given that diagram there. 8.1.1, is the above a DC or an AC generator. The correct answer and only answer, it is an AC. 912, write down the name of component X. Component X, the way I'm looking at it from the diagram given, I see it to be having slip rings as the only ones that I can see. And then 813, write down the function of component Y. The component Y, the way I see the component Y where it is, I see it is actually looking at the brushes. So it's to ensure conductivity between the slip rings and the external circuit for 1 mark, or allow the rotation of the slip rings while maintaining contact with the external circuit. So either one of the two for 1 mark. 914 is the direction of the induced current from P to Q or from Q to P. It is moving from P to Q for 1 mark. And then 9.2, the graph below shows the output voltage from a household AC generator for the rotation of the coil for 1 complete cycle. And then we are having the output there given at positive and negative 311.13, and then the time taken there it is 0.02 seconds. Now they say there 9.21, the speed of rotation is doubled. Sketch the graph of the induced EMF versus the time for this change for 1 cycle. Indicate the maximum voltage and the relevant time values. Now, let's look at it. 1, if we're increasing the speed, that means for the same 1 cycle, you are going to take a lesser time, which is going to be half of that. So 1 mark for having a period of 0.12. But also, as we are increasing the speed, we know we are going to increase the output, the voltage output, which is 1 factor that we discussed in grade 11. So that value, it is going to double to go to about 622.26. That value there, somewhere there. So plus or minus there, when we give that value, and then the mark, we are not going to change the shape. The shape of that particular, in that form, should be that AC form. Then it is 1 mark on the shape, 1 mark on the value of the amplitude, and then the value on the period for 3 marks, colleagues. And then 9.22, a electrical device is connected to this generator. The maximum current passing through the device is 8 amperes. Calculate the resistance of the device. To me, I think option 2 should have been option 1, but I'm going to read it as it is here. So for these values, we can see that is the output. It is equal to the maximum. It is 311.3. So the learner can still calculate the VRMS value, which is going to be equal to 3.13, not 2. There, you can rectify that. And then goes to 220 volts. And then from there is given the current as a maximum current passing through. It says that the maximum current passing through, it is 8. So also calculate also for that the RMS current, which is 8 over square root of 2. And then having the two values which are not having any marks, then they can calculate the resistance using VRMS equaling to IRMS multiplied by R, basically the Ohm's law, and then substituting the potential difference and then substituting that current with R and then going to R of 38.87. So the marks are on the formula, substitution on the potential difference current, and the final answer. And then option number 2, we have Vmax. They said that an electrical device is connected to this generator. So the generator is giving maximum. So already we are having that maximum voltage, we are giving the maximum current. So also there it is Ohm's law in maximum values, unlike here where it is in RMS values in option number 1. So it is max, and then we can calculate that max value, that the resistance is still going to be equal to 38,87. So the resistance of the device is not changing because it is the same material. As to whether we are using VRMS values or we are using maximum values, it's still going to work the same. So the total for that, it is equal to 4. And then number B, the energy the device consumes in 2 hours. So we are having a bit of some options there, about 6. So they can go first by calculating the power. And then from the power, then they can calculate the energy. So we have the power which is dissipated here. It is going to be the average power because it is now operating, so it is consuming. So it is going to be P average equal to RMS values for V RMS and I RMS. So as calculated before, it is 220 and 5,66. Calculating it, that average power to go to 1,245,2 watts, and then in any form, can be either in the whole, any form of power, they can calculate, being it V equal to V, P equal to V RMS multiplied by I RMS, or I squared RMS multiplied by R, because they've calculated the R, or they can still use the V RMS over the R, any form where they calculated the power, but there are no marks on that. And then go into the formula for power as a rate of change of work. Then power, they have calculated it. So whatever value that they have calculated, they substitute, and then the work is what we want. Now the time needs to be changed because it is 2 hours. Now that 2 hours needs to be changed to seconds. So that goes to 7,200, and then the value for the energy consumed then goes to 88,965,440 joules, or they can put it as 10 to the power something joules. It's fine. And then basically that is where we are going to have your 4 marks coming from. So it is going to be the formula, the substitution of the power that they have calculated, then the conversion of the 2 hours to 7,200 seconds, and then getting the final answer. That is option 1, 2, 3, how it works. And then option number 4, 5, and 6, it is already using the formula for energy as in the formula sheet. So W equal to VIT. So it can be any of those. And then the V and then the I here used, it is going to be the RMS values. So it is going to be V RMS, I RMS, and then delta T. So 1 mark for the formula, 1 mark for the substitution into V and T, and then the change in that one for the time, and then the final answer. So they work the same everywhere. So the total for that also, it is for, total for that question, it is equal to 15 marks. Any question on question number 9, colleagues, before we go to question 10? Okay, Mtate Mudukanele. Tights, askis. Tekiso, yes.
We have been observing learners for question 9.2.2 who have already doubled up the voltage as per their graph in 921. And then as a result, for everything that is seen on 922, the values are almost double. So they have used that because they thought that they must use the new device where they have 622. How can we go about with that?
I didn't get it.
Okay, and then see, I'm saying for question 9.22, the A and the B, learners were asked on earlier to draw a graph that shows the change, meaning the doubling, which will affect to the doubling of the output voltage as 622,26 volts.
Okay.
So learners have used that value of 622 to do their calculations in question 9.22, because that's what they thought was required, not the original.
All right. So in this case, they are getting everything doubled.
They are getting everything now doubled.
Okay.
Yeah.
Can I just maybe, because it is your observation that we have made, in calculating the energy, did they use the maximum or did they use the RMS values?
They have used the RMS data. They have used
the RMS.
Yes.
Okay. All right. So meaning that they are not using the 622, they are using a value lesser than that.
Definitely, yes, they are using a value that is lesser than that.
Okay, no, yes, maybe it was the way the question was put that makes that part. Colleagues, in that case, because we are marking the scale, basically we are marking the scale that the learners, they need to know that for P average, we are using RMS values. So because of the previous question, I understand where they are coming from. Yeah, if they have doubled it and then they are not using the maximum values, let us not penalize them. Let us not penalize them because we are marking the scale. Okay. Can we move on then, colleagues? Why I'm taking that is because of that opening statement. I see it is causing a bit of a problem there. An electric device is connected to this generator. And remember then the generator, there was a change that was made on that generator. That is the only way I could maybe waive that one for now. Okay. Right, question number 10. Question number 10, it says then, a learner uses two photoelectric cells to determine the maximum kinetic energy of the photoelectrons from cesium and sodium cathode. The monochromatic light from the same source is shown on the cathode of each photoelectric cell as shown in the diagram. Now we are given the diagram, and then from there it says the ammeter record a small current in each case. The learner compiles the following data for the two metals. So we're having cesium and sodium, we are having the work function, and then we're having maximum velocity of the photoelectrons in meters per second. 10.1, define the work function. Now there, work function of a metal is the minimum energy that an electron in a metal needs to be emitted or ejected from the metal surface. So we can see in the metal and metal surface are put in brackets, so they're optional. So it is part marking. But let's emphasize that minimum there, that minimum, it should be minimum energy, not minimum frequency. And if a learner makes it a frequency there, colleagues, and come to the next part, that learner should forfeit that mark there because the context is no more the same. So please be careful on that one. And then 10.2, use the information in the table to calculate the wavelength of the light used in this experiment. Now, in this case, we are using the photoelectric equation where the E can be put as a frequency. So some of the learners will first get to the frequency and then maybe calculate it, or they will just follow it the way we have done it in the memo. So we substituted the right-hand side, the Planck's constant, the speed of light, and then the wavelength is what we need. The work function substituted, and the half mass of the electron, and then the speed as they copied it from and the table then as it is. So 1 mark for the whole of that substitution on the kinetic energy, 1 mark on the substitution of copying the correct work function, and then the energy, and then calculating that it is equal into 3,5 multiplied by 10 to the power minus 7 meters. 5 marks for that. 1 mark for the formula, 1 mark, 3 marks on the substitution, 1 mark on the final answer. The totality is 5 marks. And then 10.3, for 10.3, we are going to mark it positively from 10.2, where they have calculated that wavelength. So they say they calculate the maximum velocity of the ejected electrons from sodium metal. Now it is the same line that was used. So then here we are going to put the Planck's constant as it is. The speed of light, we put in that wavelength that was calculated, 1 mark for that, and then the wavelength as they copy it from that, and then the substitutions to get to that Vmax. So that other mark there, colleagues, is not only on Vmax, it is actually for the whole of that substitution. So 1 mark for substitution on the left and 1 mark for substitution on the right. And then the final mark on the final velocity. So the total there, it is 4 marks. And then 10.4, the intensity of the incident light was increased. How does the change affect the reading on the ammeter? Write down only increase, decrease, or remains the same and explain the answer. Now, as the intensity is increased, then more photoelectrons that strikes the surface per unit time increases. So more electrons, it means, are ejected per unit time. And because of that, there will be an increase in the ammeter reading. Or the learners, they can put this last part in the form of that formula there, that I equals to Q all over delta T, and then that Q is equal to N multiplied by Q. Then for the same, we can see that T is constant and then your charge is constant. So your I will be directly proportional to N, and then that will give you more, that part that will be striking that, and then there will be an increase. So this last part, they can be put it in a mathematical form, and then we'll accept. The total for that, it is 3, and then the total for the whole of that question, it is 14. Total for the whole paper, it is 150. I see a hand raised.
Yes, Mr. Nsia, for the last time.
No, it's not for the last time, Alta. No.
Yes, it's the last time now.
Is it?
Today.
I'm going to ask you a question.
You're going to ask, okay. I just want to know from you, if a learner writes instead of per unit time, per second, do we accept it or do we penalize? Thank you.
Okay. Any other question, or maybe should I answer it? I think the time, the unit that we are using for the time, usually it is in seconds. Let us not maybe be too harsh on them. Any other colleagues? Are you okay, colleagues? Brian?
Yes, sir. Can we just go back to that question that I've asked about? Sorry, I just want to get my stuff here in order. About question 721. Pardon. Can my colleagues just check me mathematically? And then I've got another one. Question 7.1. 721, sorry, 721. Can somebody just check my mathematics, please?
10-1.
721, yes.
Yes, 721 mathematics, okay.
Please check my mathematics. And then can we go to question 3.3, option 3 and option 4?
Yes, what about them?
The answers are correct, but there are values omitted from that, from option 3 and option 4. So yeah, we did put it in. Okay, and then there must be, so it must be 2,4 equals VI times 0,7 plus, and then a half times negative 9,8.
Yes.
There's also a half short.
The half that is missing there, yes.
And then on option 4 as well.
Yes.
That's all from me. Thank you.
Thank you, Brian, and thank you, colleagues.
And Tatenzie, while we are on question 3.2, because other colleagues seems like are joining later, so they are catching up with the discussion. 7 or 3.2, if now the learner got 0.7 seconds incorrect, can we apply now positive marking for 3.3?
No.
Because now the substitution and everything will be correct. So no positive
remember,
marking.
colleagues, remember positive marking, we apply it when there is a calculation error. But this 0.7 is not a calculation. It is what the learners are reading from the graph. So there cannot be a positive marking from 3.2 to 3.3 because of that reason that I have just said, that we only apply positive marking if there is a calculation error, and then the value that we need, we are going to apply, that we have calculated, we are going to use it in the coming calculations. That's when the positive marking.
Noted. And Tatenzie, and then the other one is at 5.3, if the learner wrote kinetic frictional force.
3.5 5.3.
5.3 kinetic frictional force.
Can you go to that one? I'm not sure. 5.3. Name the non-conservative force. Okay, no, it's fine. It's fine. Yeah. Kinetic frictional force, it's fine.
And that is all I have from my side in that instance.
Okay, there is a hand. I think it's Mr. Nsapu.
There is Marisa also.
Okay. Yes, colleagues, we can.
Good morning, colleagues.
Morning, Tate.
Mr. Nzi,
That
it's not a question actually. Is there an attendance register?
Yes, sir.
There
is an attendance register. I will soon send the link into the chat now, Mine. Thank you.
Okay, thank you.
Thank you, Ntate Nsapu. There is another hand.
Hello, it's Joy here at the marking center.
Okay, Joy.
You asked for us to check the calculation of 7.2.1. We are all in agreement that it's 4 times 10 to the negative 6 coulombs. It is the correct answer.
As it is in the memo.
Yes, it is.
Thank you.
Okay.
Thank you, Joy, and other colleagues. Colleagues, in the absence of some questions, let me take this opportunity first to can just get maybe the feeling of how was the paper, and if the paper is going to help us going forward, maybe with our preparation for the final. Are there any things that were hidden in the paper that maybe we need to go and maybe emphasize as we are going through in the final preparations? And basically, how was the paper? Looking at the level of difficulty and maybe unfamiliar questions and stuff like that. Any volunteers? colleagues? Otherwise, I'm going to put people on the spot. Tate Taitsani.
Good day, colleagues. I'm looking at this paper. Question number 2. There was an inclined. And then I also looked at question number 5 and the inclined. And then if a learner did not really know much about the inclined, did not prepare well, this could have been a nightmare question paper for that particular learner. And then 2, it was question number 10, if I'm not mistaken, yes. 10.2 and 10.3. And then we awarded a mark for the same formula, there. And then it seems like we're giving the mark for the same response. Thank you, Ntate.
Thank you, Ntate. Marisa.
Okay, it's Joy.
Joy, okay.
I'm speaking on behalf of the markers here. We are 13 teachers here. You asked for feedback on the level of the paper. We are generally satisfied. We think it was a good paper, and thank you to the person setting the paper.
Thank you. Mr. Pinar?
Hello, sir. We have one small concern from Monya King. Hi, Ms. Shelley said we are marking her together at the center. And she is talking about 6.1, and the way it is phrased might be a bit confusing because it says state. The word state normally refers to giving a name or stating a simple one-word answer. If we look at the marks allocated to the question, yes, you can then derive, you have to explain something. But the word state in words, the phenomenon described above, many learners will then directly just say Doppler effect and stop there because they stated the phenomenon above.
Point taken, yes. Thank you, Rio. Any other person?
Mr. Taitsani.
Mr. Taitsani?
That was old hand, colleague, sorry.
Okay, all right. Colleagues, your points are well taken care of, and also for the examiners and moderators, they are going to look at them, that it is actually one thing that we need to look at. Like I indicated earlier, also the paper, it is intended to help our learners. So thank you very much for your contributions, and also thank you very much for being here with us and then agreeing in how we are going to mark all the learners in the Free State. I think that's all from my side. And Tate Nambane, thank you very much also for being of assistance, taking care of all the logistics. And also I want to thank also the high personnel at head office, Ntate Montsume Janetta. Thank you very much, Ntate Khopane. I see you are also there. Miss Maharaj, Dr. Maharaj, also I see you are here. Yeah, no, there are quite a number. Colleagues, thank you very much, and thank you for the support. Everyone, best of luck. Let us go and mark, colleagues, and do the moderation for the paper. Thank you. But then, don't forget the registers. And colleagues, thank you. That will mark the end of our memo discussions. And may God bless you all. Thank you from my side.
Thank you very much, and Tatensie, colleagues. As a quick reminder, the live streaming for those that were unable to watch, it's available on our YouTube channel. It has been recorded there, but remember, you will still need now to complete the register. So as soon as you have watched, kindly complete the register. We usually open it for 2 days, colleagues, just for one to be able to watch the memo discussion, because in essence we had about 49 people attending. It will usually be around 90, including those now in the YouTube. I would just like to give Memanchu to say a few words, and then we will be in a position of closing our meeting. Memanchu. Memanchu.
Colleagues, good day.
Good day, ma'am.
Dr. Nambane, can you hear me?
Yes, ma'am.
Yes,
We can
colleagues,
hear you.
thank you, Dr. Nambane. Colleagues, thank you very much for connecting to our memo discussion, and thank you very much for all your contributions. They are much appreciated. And colleagues, please, let us ensure that whatever that we've discussed and whatever that maybe we did not emphasize with our learners, let us go back and emphasize them, because remember, these examinations are actually meant to prepare our learners for the final exam. So if there are any things that we did not emphasize with our learners, or we did not make them aware that they might lose marks if they don't do them, please, as we revise, let us ensure that we emphasize those, because we want our learners to get all the marks they can. And even the mathematics colleagues, let us ensure, for example, that part where learners were told state in words, let us ensure that we emphasize all those things as write down in words, or write down the law. We want the law. But when we say in words or state in words, we want them to state it. So let us ensure that they understand the difference in all the questions that they get. But colleagues, thank you very much for all your contributions, and thank you very much for all the options that you're giving us. If, as you mark, you come across any other more options, please do not hesitate to send the options to your subject advisors so that we can discuss them. And colleagues, if you find an option, we need you to send it to us so that we can check the correctness of the option and also the allocation of the marks. Remember, we want the marking to be consistent. So where we allocate marks to substitutions, we need to ensure that we in your option, we allocate the marks to the correct substitution as well. So thank you very much, colleagues, and all the best with your learners. All the best for paper 2 that they are writing right now. And hope your learners will pass. And all the best again for the final exam. All the grade 10s, 11s, and 12s. Thank you very much, colleagues. Goodbye. Thank you, Dr. Nambane.
Thank you very much, Mebusi. Colleagues, have a lovely day. Thank you.